In this tutorial, I'm going to discuss how to calculate cross-elasticity of demand. I'm going to show you the theory or the idea behind it, and I'm also going to do a couple calculations as well. So imagine a substitute good, and I put along the x-axis quantity x, and along the y-axis, the vertical axis, price, and I draw in an individual demand curve. Price and quantity are there. And again, this is individual demand. Imagine another good, price of y, goes up, it rises, and the demand of x increases. Price remains the same, but quantity increases. Quantity goes up, but price remains fixed because an individual consumer can purchase all they want at that price. Quantity increases, and it increases from quantity 1 or Q1 to Q2. That's what makes it a substitute good. Now imagine Pepsi is good X and the price of Coke, good Y, goes up, and that causes the demand for Pepsi to increase. Another example is imagine the price of gasoline go up and the demand for bus tickets to go up. Substitute goods. I'm going to calculate the percent change in quantity, and that little triangle there is equal to the change, which is delta. I'm also going to calculate the change in price of good Y, and I'm going to call that percent change in PY, where PY is equal to price of good Y. So good Y goes from price 1, PY1 to, and rises to PY2. So I take the percent change in quantity divided by the percent change in price of good Y. This is equal to the second quantity minus the first quantity divided by the first quantity. Let me show you this on the graph. Q2, that's the second quantity, minus the first quantity divided by the first quantity. So I have Q2 minus Q1 divided by Q1. I divide all this by the second price of good Y minus the first price of good Y divided by the first price of good Y. Or PY2, that PY2 minus PY1, that PY, divided by that PY2. So I have PY2 minus PY1 divided by PY1. To get percent change, I would multiply by 100, but those hundreds actually cancel out, and you may not see those in your textbook, or your professor may not even show those to you. And this, my dear students, is the equation for cross-elasticity of demand. It's the percent change in quantity demand of X divided by the percent change in price of good Y. Now a calculation. So imagine that I have price of good Y and quantity of good X, and the price of Y goes from 1 to 2, and quantity increases from 20 to 40 for good X. I draw in the demand curve, individual demand curve of quantity of X, and the price is here, and the quantity demanded here is 20. Demand increases, and quantity demanded increases to 40. So now I can make a calculation. I take the second quantity minus the first quantity divided by the first quantity. All this divided by the second price minus the first price divided by the first price. This is equal to 40 minus 20, which is 20, plus 20, divided by 20. All this divided by 2 minus 1, which is 1, divided by 1. This is equal to 1 divided by 1. It's equal to 1. That makes it a substitute good. It has a positive sign. This time imagine that price goes up from 1 to 2, but quantity of X demanded goes from 20 to 10. I draw in the individual demand for a quantity of good X, and with a price right there, and also this time a quantity of 20 as well. But this time demand decreases and quantity demand becomes 10. This good is called a complementary good. They complement each other. iPhones and iPhone apps are great examples of complementary goods. The price of iPhones go up, the demand for iPhone apps will go down. So now, I'm going to put this into an equation. So I take 10 minus 20 divided by 20, which is the first quantity. Divide all this by the second price, which is 2, minus the first price, which is 1, divided by the first price, divided by the first price. This is equal to 10 minus 20, which is negative 10, makes it a complementary good, divided by 20. This whole thing divided by 2 minus 1, divided by 1. This equals negative 0.5 divided by 1, which equals negative 0.5. The whole thing equals negative 0.5. So the equation is percent change in quantity demand of X divided by the percent change in the price of Y. If I have individual demand, some price and some quantity, the price of good Y rises and demand goes down. This is an example of a complement good, where the goods are complements to each other, and the sign of that equation is negative. Now imagine price of good Y goes up, the demand of good X increases, price remains the same, but quantity increases from Q1 to Q2. Good Y and good X are substitutes, and that equation is a positive. So now, if the sign of that equation is positive, good Y and good X are substitutes. If it's negative, good Y and good X are complements. If the price of good Y goes down and quantity goes down, the goods are substitutes. Now, the price goes down, quantity goes down. Now, if the price goes down from 1 to 0.5 and quantity goes up, they're complements. Good Y and good X are complements. They complement each other. So in the end, price of Y, quantity of X, price of Y goes down, quantity of good X demanded goes down. They move in the same direction. They are substitutes. Price of Y goes up, quantity demand of X goes up, substitutes. Price of Y goes down, quantity demand of X goes up. They be complements. Good X and good Y are complements. As always, share the knowledge, share the love. Don't be hating. Like us on Facebook, Google+, and Twitter. Questions, comments. Make sure you like the videos as well. And make sure you subscribe. I'm always posting new materials to help you in economics.